All right. File number K98A.htm. Point 10. Expanding universe, Big Bang theory. Many of the most favored Big Bang versions are already having severe problems thanks to the findings of new instruments such as the Hubble Space Telescope. For example, some measurements which were used to calculate the rate of the universe's expansion, if indeed the redshift of light means expansion at all, would have meant, if such cosmic revolutionary speculations were factual, that the universe was younger than the alleged ages of some of its stars. As optical telescopes are improved, enabling astronomers to look for even further out in space, Big Bangers have eagerly expected that there would be a consistent pattern found, such that at greater redshifts, soon to be bigger distances, there would be ever younger, in cosmic evolutionary terms, galaxies. It turns out that most of the galaxies at high redshifts are indeed dominated by blue stars. This is the color which present theory expects from stars which have not been burning as long as red ones. And there is a striking variety of shapes. While this is not very specific, it does match the Big Bang's expectations in a general sense. It could also match a number of creationist cosmological scenarios as well. However, it only takes one black swan to disprove the notion that all swans are white. And there are in fact several galaxies in the same redshift zone which are not blue but red. The most perplexing such galaxy to date has an apparent age, according to evolutionary theories, of 3.5 billion years, which is far too old for a galaxy at such an allegedly early stage, redshift 1.5, of the universe's history. The end of the Big Bang? In addition, the distant universe is causing a headache by being far too clumpy for the popular Big Bang scenario. About a decade ago, astronomers doing large-scale 3D mapping of positions of galaxies were surprised to find that the universe was incredibly clumpy, with huge sheets of galaxies, one dubbed the Great Wall, alternating with massive voids. Even back then, it was stated that there should not have been enough time for an exploding mass to form such large-scale structures. Although cosmologists had a hard time learning to live with this reality, they could at least comfort themselves with the knowledge that the early universe would turn out to better match their predictions by looking back, i.e. out far enough. The universe would get progressively smoother. Unfortunately for the theory, it is beginning to look as if it is just as lumpy a long way out. Preliminary observations strongly suggest that there are many structures the size and shape of the Great Wall, but dozens of times farther away. In fact, such clustering is turning up in one part of the sky that includes the faintest and most distant galaxies observed. Question again, will this mean the end of the Big Bang? We suspect not, because this model has long been noted by some of this to be sufficiently vague to be remarkably flexible. Presumably, if the past is any guide, twiddling a few more knobs on the model will probably be able to salvage it once more. There are all manner of variables which can be shuffled at will in computer models. Changes in the expansion rate, the density of mass in the universe, one can assume almost any amount of invisible dark matter, the existence of a hypothetical cosmological constant. There have even been suggestions that the law of gravity may not have been the same in the early universe. Therefore, it is no surprise that the seeming conflict between the age of the universe and the age of some of its stars has almost been solved by some frantic adjustments. Calculations giving ages of the oldest stars range from 12 to 15 billion years. Astronomers now are coming to agreement on an age range of the universe of 8 to 12 billion years. As close as the overlap is, it is enough to save the day for the moment. Redshifts. However, there is another set of awkward, uncomfortable observations which have loomed in the background for around 20 years now. What's way back, which, if correct, have been said to have some awesome implications, even to the extent of being the death knell for any Big Bang concept. The observation is the quantization of redshifts, and has even been said that to undermine the very idea that the universe is expanding. What is it about? Astronomer William Tift of the University of Arizona was the first to claim that the redshifts, the degree to which the light from stars is shifted to the red end of the spectrum, which is supposed to measure the speed at which the star is moving away, and hence how far away it is, of galaxies fall into distinct packets of quanta, like the rungs of a ladder. This would be like saying that if you measured the speed of particles coming out of an explosion, instead of being evenly distributed across a range of velocities, they fell into groups. For example, 100 kilometers an hour, 200 kilometers, 300 kilometers, and so on. Tift was ignored at first, but continued to amass data for many years, most showing the same effect. Now, in a major study of more than 200 galaxies using very sensitive equipment, 2 UK astronomers, Oxford's Bill Napier and Bruce Guthrie from Edinburgh, claim to have the best evidence yet that the phenomenon is real. This time, even some former skeptics of the claim are taking it seriously enough to warrant getting involved in the debate, suggesting proposals to test it further, and so on. Mike Disney of Cardiff's University of Wales says that if it keeps on holding up, it might turn standard cosmology on its ear. He says it would mean abandoning a great deal of present research. All attempts to try to explain it within conventional models are, to be put it mildly, highly unorthodox. And it is stated that if it does survive the next round of tests, theorists will have a sticky problem trying to explain it. James Peebles of Princeton, whose pet bang cosmology is the big loser if this is right, says he treats the claims with extreme caution for this very reason, saying that he is not being dogmatic and saying it can't happen, but if it does, it's a real shocker. However, the data are already very impressive. According to Bill Napier, they tried hard to avoid concluding that the redshifts were quantized, but failed. There seems little doubt that if these observations did not conflict with the Big Bang, they would have been taken much more seriously a long time ago. The problem seems to be, as prominent astronomer Jeffrey Burbidge puts it. Burbidge is professor of physics at the University of California, San Diego. Big Bang cosmology is probably as widely believed as has been any theory of the universe in the history of the Western civilization. It rests, however, on many untested and, in many cases, untestable assumptions. Indeed, Big Bang cosmology has become a bandwagon of thought that reflects faith as much as objective truth. Unfortunately, some of those who promote the alleged Big Bang as an article of faith are Christians. They claim it is a fact of nature, which must therefore be accepted, and Genesis must be reinterpreted to suit this and other concepts held by evolutionists. Such facts of nature, in their view, are a source of revelation and a par with the Bible. For example, Dr. Hugh Ross writes, "The facts of nature may be likened to a 67th book of the Bible." The problem with this idea, now being enthusiastically embraced by many leading evangelicals, comes when one has to face up to the reality that all such facts, quote unquote, can only ever be the interpretations and conclusions of fallible, finite people biased by nature against their maker. Many who have been swayed by such attempts to harmonize the Bible with evolutionism will have to hunt around for a new interpretation of Genesis if, or perhaps one should say when, the Big Bang is discarded by the secular world in their lifetime. Of course, such abandonment would only be undertaken once an alternative concept has been thought up, which fitted the data at least well enough to continue to assist an unbelieving world in its vain attempt to try to explain the origin of the world without God. Newton's first two laws of thermodynamics confound the Big Bang theory, and galaxy-quasar connection defies explanation and contradicts the Redshift expanding universe theory. Take a look at this. Two conflicting laws. In the early 20th century, physicists came to realize that energy and mass are equivalent. Surprisingly, energy has mass, and matter has intrinsic energy due to its mass. Energy can be converted into matter, and the energy in matter can be liberated into other forms following Einstein's famous equation E equals mc squared, where E is energy, m is mass, and c is the speed of light. This means that the universe contains a tremendous amount of energy, not just in conventional forms, but as matter. So where is the problem for secular scientists? Physicists have long recognized the first law of thermodynamics, that energy can neither be created nor destroyed. Since matter and energy are equivalent, the sudden appearance of all the matter in the universe would violate this fundamental physical law. So for a long time, physicists thought the universe was eternal, that it had always existed. This certainly would avoid the problem with the first law of thermodynamics, often called the conservation of energy. But the second law of thermodynamics presents a problem for this view. While the first law says that the total energy of the universe does not change, the second law decrees that the amount of energy useful for the work is continually decreasing. Eventually, given enough time, all the energy in the universe would equalize. Without useful energy, work is impossible. Life would be impossible. Physicists call this heat death, and it is the far-off future of the universe without God's intervention. But if the universe is eternal, it would have long since reached heat death. Clearly, this is not the case. So the universe cannot be eternal. This means it had a beginning when energy was created, but this would violate the first law of thermodynamics if you naively assume that the first law was applicable at the universe's creation. In the world today, the first and second laws of thermodynamics work together hand in glove. They appear to be universally true, and they are among the most fundamental and basic laws of physics. Furthermore, scientists expect that the two laws will apply in the future and that they have applied in the past. However, when these two laws are applied indefinitely into the past, we reach a contradiction. How do we resolve this dilemma?